In this video, we're going to discuss an introduction to graphing. So first of all, it says here an equation that can be written in the form ax plus by equals c is called a linear equation. The graph of a linear equation is a, what do you think? Well, notice the word line in linear equation. In fact, that's what you get when you graph a linear equation. Number two, we're supposed to graph these points. So 1, -2 would be right there. Basically what we have here is an ordered pair, and the first value is an x value, or the x coordinate, or x ordinate. And then we have the y value, which is -2. So in this case, we start at 0, 0, which is called the origin. And we're going to go 1 in the positive x direction, so that takes us to here. And then we're going to go -2 in the y direction. Now the y-axis, positive is up, negative is down, and so we're going to go down 2. And so starting from the origin, we go 1 to the right and down 2. All right, so I would encourage you to graph the other 3 points and then check your answers. So you should get -4, -5 there, 0, 4 there. Notice you go 0 in the x direction, so you don't move from the origin, and then you just go up 4. And then finally we have -5, 2 right there. And when we label our quadrants, the first quadrant is where x and y are both positive, and then it's like a capital C. We go counterclockwise, and so these are our quadrants, and so you can see that the point 1, -2 is the one that's in quadrant 4. So make sure you know your quadrants. So this is what we call the xy axis, or the coordinate plane. You have an x-axis, you have a y-axis, so you should be familiar with that. We're assuming that as we talk about graphing here. So it says determine whether the following are solutions to the equation 9x minus 8y equals 4. Well, this is an equation. I'm going to go ahead and make a shell of the equation. So wherever there was an x, there's parentheses. Wherever there was a y, there's parentheses. And we're going to go ahead and plug in our values. So 1 is our x value and 1/2 is the y value. We're going to get 9 minus, now 8 halves, or 8 times a half, is 4. So 9 minus 4, we want to know if that equals 4. Well, that's 5 equals 4, which of course is not true. It's false. And so the answer is no. This is not a solution to the equation. So what about the ordered pair 2/3, 1/4? So again, I'll make a shell, and let's go ahead and plug in 2/3 and 1/4. Now, you should be able to do this fraction arithmetic by hand, but you also have your calculator, and you certainly should be able to check it on the calculator as well. So when I multiply 9 times 2/3, I would write that as 9/1, and we just multiply straight across. We get 18/3, which is 6, and that'll be minus 8/4, that would be 2, but again, you can multiply 8/1 times 1/4, you get 8/4, or 2, and of course 6 minus 2 does equal 4, and so this is a solution. So there's a question I'd like to ask you at this point. How many solutions are there to a linear equation? So in fact, we say there are infinitely many. In fact, every point on the line represents a solution to the equation. Any point or ordered pair that's not on the line would not be a solution. All right, let's move on to the next slide. So here it says graph the linear equation y equals -2x plus 5. Now it turns out there's 3 ways that we use to graph lines, and so in this lesson we're going to be looking at the first method. So basically we make a table of values. You do your little XY chart. And so I don't know about you, but I like to keep, we basically have infinitely many points to choose from. And so I would choose x equals 0. That's my favorite choice. And when we plug that in, we get negative 2 times, we're just plugging that into the equation. Y equals negative 2 times 0 plus 5, which of course is 5. And so let's go ahead and plot 0, 5 on the graph. And there's really no reason not to go ahead and choose 1 next. Again, I'm trying to keep this simple. So negative 2 times 1 plus 5, that's going to be 3. And so we'll plot the point 1, 3. And then we normally find 3 points. Notice 2 points are enough to draw the line. So why do you think we find a third? Well, you may have guessed it's because it's a check. If your next point is here, you know something's wrong because you're expecting the graph of a line. So let's find one more point. So let's go with 2 for x. When you plug in 2, you get negative 2 times 2 plus 5, and that's going to be negative 4 plus 5, or 1. So 2, 1 is on the graph, and you can see that the points do line up, and so there's our solution. And so remember, every point on that line represents a solution to this linear equation. All right, I would encourage you to try the next 2 and then watch the video. So I do want to make a comment here. A graph gives us a picture of all the solutions. In fact, sometimes students will say, why do we have to do all this graphing stuff? Well, it turns out when you solve when you have a linear equation like this, there's not just one solution. Like if I were solving the equation 2x equals 5, I would divide both sides by 2 and I'd get 5 halves. And so 5 halves is the one and only solution. But with these linear equations, we have infinitely many. And in fact, if we didn't have a picture, it would really not be there wouldn't be a great way to really show your solution. In fact, there was a time when algebra didn't have pictures at all. And basically, we eventually tied algebra and geometry together, and so now we have a visual. And for most of us, we like to have a picture. It makes things easier to understand. All right, let's move on to number 5. So I'm going to make a table of values, and 0 looks to me like a pretty good choice, so I'm going to start with 0. 0 usually is a good choice. And so when we plug that in, we get y equals 1/3 times 0 minus 4. Well, 1/3 times 0 is 0, so we'll get 0 minus 4, which is negative 4. And so 0, negative 4 is on the graph. Now here's where you got to be careful. I'm going to go ahead and pick 1, but I want you to notice that's not a good choice here. So when I plug it in, I get 1/3 times 1 minus 4, which is 1/3 minus 4. Well, let's see, just take a third from 4 and make it negative. That's negative 3 2/3. So I don't particularly care for that ordered pair. It's got a mixed number in it, so I'm not even going to graph it. Let's think about this a little more carefully. What we really want to do is pick an x value that will cancel with this 3. We really need to choose multiples of 3. Because if you had 1/3 times 3 or 1/3 times 6, then the 3 would be canceled out, and that's what we want. And so you should be choosing multiples of 3 in a case like this. So let's choose 3. So we plug in 3. Of course, 1/3 times 3 is going to be 1. Those are in fact reciprocals. And 1 minus 4 is negative 3. And so 3, negative 3 goes there. And again, I want to find one more point. Let's go ahead and use 6. So we get 1/3 times 6 over 1 minus 4. 6/3 is 2. 2 minus 4 is negative 2. And so finally you can see our points line up, and I've drawn the line. And so that's our solution to this, actually a picture of all our solutions, and that's the equation that we would graph here. Now number 6 is going to be a little bit more difficult. Notice it's not solved for y. I should say it's going to be more difficult if we're choosing x values first. In fact, this equation could be solved for x, and that would be the easiest way to pick points. You would actually pick y values first. But I'm going to go ahead, normally in a case like this, we would want to solve for y first. So let's go ahead and do that. I do want to make a comment here though. What we're doing when we use the table of values to graph is what's called graphing by plotting points. And so that is the technique we're using. It turns out there's a better way to graph linear equations most of the time, but graphing by plotting points is a technique that we need to master because it's going to be very helpful with all sorts of different types of equations, not just linear. All right, so on number 6, I'm going to go ahead and subtract x on both sides. I get negative 3y equals minus x plus 5. And so we'll divide each side by negative 3. We get y equals, let's see, negative 1, that's a negative 1x, over negative 3. We can split this into two fractions, and then we have plus 5 over negative 3. And it didn't end up turning out to be all that good of a choice here. You can actually graph this using another technique, but we really don't like this. This is actually the y-intercept here. We don't like this value here. So let me show you probably the easiest way to do this. I kind of mentioned it before. Let's go ahead and choose a y value first. Notice, we could even just solve this thing for x, but if we choose y first, it's going to make things easier. If we plug 0 in for y, we get x minus 3 times 0 is 5. So x is going to equal 5. So 5 zeros on the graph. And let's go ahead and plug in 1. So x minus 3 times 1, that's going to be x minus 3 equals 5. We'll add 3 to both sides, and we get 8. So 8, 1 is on the graph. Kind of takes me off the grid there. And then let's see. Let's plug in negative 1 for y. You could see as we were getting bigger with y values, that was taking us off the grid. So let's try a negative value. And so x minus 3 times negative 1, that's going to be plus 3 equals 5. And so we're going to get 2 there. And so our graph's going to look like that. And I'm going to go ahead and stop here, and we'll do a second part.